This question is about modern physics, and modern physics, basically the equations are tough to memorize. Okay, and see here, they are actually playing with the equations. Consider a hydrogen atom with what? Vk, Rk, and Kk, denoting velocity, orbital radius, and kinetic energy of the electron in the kth orbit. The electron undergoes a transition from the nth orbit. So this is about kth orbit. You are talking about nth orbit. So ഇതിൽ എല്ലാ ടേമിന്റെയും kക്ക് പകരം n ആയിട്ട് മാറും. Emitting radiation corresponding to the Lyman series. So this is Lyman series means it should be from nth orbit to the ground state. അപ്പം n to 1 ആണ്. Transition is from n to 1. H is Planck's constant, epsilon 0 permittivity, correct statement. ഇതിൽ ഓരോ സ്റ്റേറ്റ്മെന്റിന്റെയും നോക്കൂ, we already know equation for kinetic energy. They want the change in kinetic energy, but the equation is a bit different. We know de Broglie wavelength, but the equation is different. We know frequency, but the equation is different. Magnitude of change in total energy. Okay, this is relatable. Kinetic energy and total energy should be identical, but ഈ equations നമ്മൾ derive ചെയ്യണം. So let us start from the option A given, and you want an equation like this. Noku, kinetic energy in terms of h4 pi nv and r. How to find kinetic energy in that format? Of course, in the examination hall, it's not very easy. But when I independently discuss it, I have actually had enough time to think about this thing. So it's prepared class, not a like a instantaneous one file. We already know that from Bose postulate, MVR is nothing but NH by 2 pi. MVR is NH by 2 pi. From this I am writing MV equal to NH by 2 pi R. Now what is the equation of kinetic energy? Normally kinetic energy written as half mv square. So I am writing it as mv into v, so that I can substitute that mv here. So this kinetic energy will become half nh by 2 pi r into v, will give you nhv divided by 4 pi r. So isn't that your form here? nhv by 4 pi r, same thing. So then now it's easy. Now this is coming from nth orbit to the ground orbit. Of course, nth orbit, the kinetic energy will be less, ground orbit will be more. So naturally, if you take the change in kinetic energy, I'm taking change in kinetic energy delta k. I can take it from initial minus final, final minus initial. Normally we do final minus initial. പക്ഷെ ഇവിടെ ഓപ്ഷനിൽ അങ്ങനെയല്ല കാണുന്നത്. നോക്കൂ, ഇത് n അല്ലേ, nth orbit, initial ആണ്, ഈ 1 ground ആണ്. So I'm taking k in the nth orbit minus k in the first orbit. So that'll give you delta k equal to nth orbit. Nth orbit അത് nhvn divided by 4 pi r in n. Minus first orbital n in the value 1 ആണ്, h v in 1 divided by 4 pi r in 1. Common term ആയിട്ടുള്ളത് ഏതാ നോക്കൂ, h by 4 pi is common. In the bracket you'll get n vn by rn minus v1 by r. So this is delta k. But see, നമ്മൾ ഇങ്ങനെ calculate ചെയ്യുമ്പം its value will become negative. Value will be negative. See, once you know the magnitude, so that means the option 1 is correct. Option 1 correct. Now you can directly jump to option D. What is asked? Magnitude of change in total energy. Magnitude of total energy. I can write here total energy change in minus delta k. Kinetic energy and total energy are related like that. Therefore, delta k and its magnitude must be, see, ഇവിടെ തന്നിരിക്കുന്ന order നോക്കൂ, they are taking first one, then the nth one. If I do that one, I should get h by 4 pi bracket v1 by r1 minus N Vn divided by R. This is delta E. I'm sorry, not delta K. It is delta E. It should be delta E. But in the given option, you can see that the 4 pi is missing. It is 2 pi. So this option is not correct. Second one is not correct. Okay. So by forming this spatial equation, we are able to solve two of them. Now what is given? Now what is given is you have to find out what you call de Broglie wavelength. To find out de Broglie wavelength, let us write the equation of de Broglie wavelength. How to write de Broglie wavelength? De Broglie wavelength is written as lambda equal to h divided by root 2m into kinetic energy. Okay, that is the equation for de Broglie wavelength. But in this equation given, we don't see anything. Instead of that, there is kinetic energy. Kn and K1 are kinetic energy, but in our equation it is root of kinetic energy. So we need to change this one. And more than that, do you see H here? H is absent. So why can't we substitute H from this one? We already know that kinetic energy is given by, in hydrogen atom, kinetic energy is given by m e raised to 4 divided by 8 epsilon 0 square h square n square. We already know this equation. Now from this we can write h square equal to m e raised to 4 divided by 8 epsilon 0 square n square into k. From that h is equal to root m e square divided by root 8 epsilon 0 n root k. This is the equation for Planck's constant. Now we will substitute that here. Okay, space is important. Okay, so this is h1 by root 2mk multiplied by root m into e square divided by root 8 epsilon 0 n root k. So hopefully we'll get the de Broglie wavelength here. You can see that root m cancels out. Okay, and 8 into 2 16. 16 root is 4. So this will give you 1. This will give you again yes, e square divided by 16 root is 4. Then you can see that epsilon 0 is there, n is there, root k into root k is k. So successfully we did this equation, e square by 4 epsilon 0 nk. E square by 4 epsilon 0 nk is equation for de Broglie wavelength. Now they want the change. Again see that change from the nth orbit to the ground orbit. So the change in de Broglie wavelength, I'll just okay, change in de Broglie wavelength. This is the equation delta lambda. I'm writing it here. Delta lambda equal to see the option e square by 4 epsilon 0 is constant. E square by 4 epsilon 0 bracket from the nth orbit. From the nth orbit, what should I get? From the nth orbit, I should get 1 by nk minus first orbit I'll get 1 nkn, and first orbit I'll get 1 by k1. So that is the equation. Okay. So we can see that this term, something is missing. What is missing? That n is missing here. This n is not here. That is why this option is wrong. Actual equation is this one. Okay. This is the equation for de Broglie wavelength. Alright. So we are successfully we completed. We know option A is correct, option B is not correct. Now frequency of emitted radiation. Frequency of emitted radiation. How to do frequency of emitted radiation? Frequency, see the equation. It is given in this format. E square by 8 pi epsilon 0 h into R1 Rn. So that I think is pretty easy, because we know in Rutherford model as well as in Bohr model, the centripetal force is given by electric force between the electron and the proton, that is E square by 4 pi epsilon 0 R square. This is equation for force. From this I can easily find out, see, one of these are cancelled, then I can easily find out that kinetic energy is nothing but E square divided by 8 pi epsilon 0 r. E square by 8 pi epsilon 0 into r. This is the kinetic energy. Okay. Now, when an electron, this is the kinetic energy. Okay. Now, when the kinetic energy is given, what is total energy? Total energy is equal to negative of kinetic energy. So, that is A square by 8 pi epsilon 0 r is the total energy of the electron in the orbit. Now, when an electron makes a transition, we know that it sends the remaining energy in the form of a photon, and that energy is given by h nu equal to we know that is En minus E1, because En is a higher energy, E1 is a lower energy, En minus E1. Okay, we want the frequency. The frequency h nu equal to, in this term, which are the common terms okay, we can write that En means it is E square minus E square divided by 8 pi epsilon 0 Rn minus minus E square divided by 8 pi epsilon 0 R1. H nu equal to E square by 8 pi epsilon 0 bracket 1 by R1 minus 1 by Rn, because this minus and minus become plus. Okay. Now you want the frequency. Now the frequency is given by E square divided by 8 pi epsilon 0 h bracket 1 by R1 minus 1 by Rn. This is the equation for the frequency emitted. And this equation is exactly the same thing, E square by 8 pi epsilon 0 h into 1 by R1 minus 1 by Rn. See, this is totally like, it's not a tough question conceptually. It's a play of equations. And in the 1 or 2 minutes available, under that stressed out situation, handling this is really not easy. Question will become really tough.